Hello, med students. This is P. Venkateshwarlu, PGT Physics. Yesterday we discussed, or in previous video we discussed with viscosity and differences between viscosity and solid friction. Okay, so viscosity means whenever fluid flows in a particular pipe, canal, in which fluid can flow layer by layer. Okay, understand, layer by layer. So in which between the layers of fluid friction comes into play, which opposes the relative motion between the layers of fluid, is called viscosity. Okay, so how we can say more viscous and less viscous of the fluid? So if water flows, if water flows smoothly, we can say less viscous. If fluid flows very hard, listen, I will give one example. So consider a mug and pour water and drop it. What you can observe, water falls fastly. In the same way, you consider honey or castor oil. Honey, you can take honey. How you can take honey? How much time you need to take honey drop from the bottle? See the time will say which is more viscous, which is less viscous. Understand? And we discussed the differences between viscous friction or fluid friction and solid friction. Understand? Solid friction is independent of area of cross section, but here fluid friction which is depends upon area of the layer. Understand? Now in this video we'll discuss about factors affecting on viscosity, temperature, effects of temperature of the viscosity. Effect of temperature. Effects of temperature on the viscosity. Effects of temperature on the viscosity. Here what happened, my dear children? See, the temperature will increases, the viscosity it may decreases or increases. Now we'll discuss it. So in the form of liquids, for liquids, the viscosity which is inverse proportional to the temperature. Understand? So this is for liquids. Temperature increases, their viscous force decreases. Understand, my children? If temperature increases, viscosity decreases. Understand? If temperature decreases, viscosity increases. Understand, my children? So next, for gases. So this is for liquid. For gases, what? Gases. Now viscosity is directly proportional to temperature. Understand? For gases, temperature increases means viscosity also increases. Temperature decreases means viscosity also decreases. Understand? So what is viscosity? Remember, my children, remember. So when fluid flows in canals or pipes, whatever may be, fluid flows by layer. So in this process, between the layers and layer, a friction come into play. That friction we can say viscosity or viscous force. Understand? Fluid friction. Understand, my children? Then now we are going to discuss about critical velocity. My children. What, my children? Critical velocity. Critical velocity, VC. It is denoted VC. See here what happened, my dear children. So whenever fluid flows layer by layer, or we know that streamline flow, laminar flow and turbulent flow. Okay, understand? So here in streamline flow, each and every particle moves in a lines. Okay, layers of the lines. Understand? Each particle moves in a straight line. Okay, or curved path. Okay, understand? Each particle followed preceding particle. Okay, so if the particle moves one direction, remaining backward particles also, what liquid particles also move same direction. Okay, understand? So coming to laminar flow. Laminar flow means the fluid flow in the form of layers. Okay, so one layer moves towards right side means it pull back another layer, below layer and above layer. Understand? Turbulent flow. Okay, when water flows in canals and any disturbance is there, the direction of water is whirling nature. Okay, understand? Suddenly high, suddenly low. Okay, this we can say turbulent flow. Turbulent flow. Okay, understand my children? Coming to this critical velocity, the limiting value of streamline flow. Limiting value of streamline flow. Okay, so if the value exceeds, we can get turbulent flow. Okay, so if critical velocity increases means we can get turbulent flow. Okay, if critical velocity increases, streamline flow, it becomes what now? It becomes a turbulent flow. Understand? So the limiting value of streamline flow is called critical velocity. Critical velocity, which is depends upon viscosity, density and radius of the pipe. Okay, understand? Then critical velocity is directly proportional to density of the fluid. Understand? Critical velocity is directly proportional to what now? Viscosity or fluid friction. And critical velocity is directly proportional to the radius of the pipe. Understand my children? Okay, critical velocity depends upon, which is directly proportional to viscosity, which is directly proportional to density, it is directly proportional to what, my children? Radius of the pipe or radius of the container. Okay, understand my children? See here, this is the relation. Okay, understand? This is the relation. How we can find the relation among them? Okay. So what is the relation, my children? VC is directly proportional to N rho R. Okay, understand? So VC is directly proportional to N rho R. If we can take constant, that is K. Okay, K into eta rho R. So this is the relation. Okay, how we can find their values? Suppose it is A, it is B, it is C. Okay, so how we can get this exact formula? How we can establish their relation? Okay, so by using applications of dimension formula. Okay, so very important this method. Okay, how we can establish this exact relation? By using applications of dimensions, which is very important one, NEET and JEE. Okay, so very important coming one. Okay, so how we can derive this relation means by the applications of dimension formula. Okay, so here by using dimensions we can establish the relation among the variables. Okay, understand? So in this case what we have to do, LHS is equal to what? LHS VC, what is the dimension formula? M power 0, L power 1, T power minus 1. Okay, because it is critical velocity. Okay, coming to RHS, okay, it is K is constant. We can get N power A, rho power B, R power C. N power A, rho power B, R power C. N power A is there. So what is N? N is equal to viscosity. We can get force per unit area. Force per unit area per velocity gradient, dV by dx. Understand? So we have to write M power 1, L power minus 1, T power minus 2 divided by here M power 0, L power 1, T power minus 1 divided by L power 1. Okay, L power 1 gets cancelled. Okay, here T power minus 1, T power minus 2 gets cancelled. Here M power 1, L power minus 1, T power minus 1. Okay, understand my children? See here M power 1, L power minus 1, T power minus 1 whole power A. Okay, so next density my children. What is density? Density mass per unit volume. Okay, we can get M power 1, L power minus 3, T power 0. Okay, so we can get M power 1, L power minus 3, T power 0 whole power B. Next, our radius L power 1. Okay, C. Understand? So by taking this, okay, so we can rearrange this. We can get a complete RHS. RHS is equal to, so rearrange this M power A, L power minus A, T power minus A, T power minus A. Next, M power A, M power B, L power minus 3B, L power minus 3B. Next, T power 0. Next, L power C. Okay, rearrange this M power A. Next, B, M power A plus B. Next, L power minus A minus 3B plus C minus A minus 3B plus C. Next, T power. T, how much? T power minus A. Yes, T power minus A here, there is no T. Okay, so by comparing LHS and RHS, so we can equate M power 0, L power 1, T power minus 1 is equal to M power, here M power, this is B, M power A plus B, L power minus A minus 3B plus C, T power minus A. Okay, understand? Consider M power 0 is equal to M power A plus B. Okay, 0 is equal to A plus B, that is equal to A is equal to minus B. Okay, my children, A is equal to minus B. Okay, next T power minus 1 is equal to T power minus A. Okay, understand? So then we have to write minus 1 is equal to minus A. Minus gets cancelled. A is equal to 1. Then from this both we can get B is equal to minus 1. Okay, understand my children? How we can get C? Remember my children, C. we can get L power 1 is equal to L power minus A minus 3B plus C. Okay, understand? Remember my children? Okay, so if not, I will explain here. Okay, be careful. Consider L power 1 is equal to L power minus A minus 3B plus C. Okay, 1 is equal to minus A minus 3B plus C. Okay, 1 is equal to minus 1 minus 3 minus 1 plus C. Minus here 1 is equal to minus 1 minus 3 plus C. Okay, understand? Here minus 1 minus 3 plus 3. Okay, understand? Then 1 is equal to minus 1 is equal to 2. 1 is equal to 2 plus C. Okay, then C is equal to 1 minus 2 minus 1. C is equal to minus 1. C is equal to minus 1 minus 1. C is equal to what? Minus 1. Okay, understand my children? C is equal to minus 1. See, by rearranging, by using these dimensions, we have to find A, B, C. K is constant. Okay, so what is A? 1. What is B? Minus 1. So what is C? Minus 1. By taking 3, we can establish this relation. Okay, understand? So by removing this, we have to take the values. A value 1, B value minus 1, C value also minus 1. Okay, so we have to write critical velocity is equal to K constant eta power A and rho power B R power C. Okay, this we can write. This we have to write. Critical velocity is equal to K into eta power 1. B how much? B minus 1. Then C also minus 1. R power minus 1. Okay, so Vc is equal to K into rho divided by rho into R. Okay, my children, this is the exact relation. This is the exact relation between the coefficient of viscosity, density of fluid and radius of the pipe, okay, in which the fluid can flow. Okay, understand? So what is critical velocity? Critical velocity is the limiting value of fluid flow in a streamline. If exceeds, we can get turbulent flow. Okay, understand? See this derivation, how we can get the relation, how we can establish the relation between the quantity, which is the application of dimension formula. Okay, applications of dimensions, which is very useful for NEET and JEE. So this is the way to establish the relation among the quantities. Okay, understand? This is the formula. Okay, understand? So next, how we can get streamline flow? Okay, how we can get streamline flow? Streamline flow means, okay, if eta value increases, means high viscous fluid, then less density and less radius of pipe will give the streamline flow. Okay, if we can take high viscous fluid, less density, high viscous fluid and less density with less radius of the pipe, we can get a streamline flow. For the opposite, if we can take less viscous and more density and more radius of the pipe will give turbulent flow. Turbulent flow. Understand, my children? Understand? So if we can take viscosity increases and density decreases, and we can say radius also decreases, this flow is called what known as streamline flow. So then viscous decreases and radius and density increases in a particular pipe, we can say that is a turbulent flow, my children. Okay, understand, my children?